Algebra 2, target 27. I can solve exponential and logarithmic equations. Today's the second day. In the first part of target 27, you looked at solving exponential equations. Today we will focus on solving logarithmic equations. So just as with exponential equations, there are two basic types of logarithmic equations that we're going to learn how to solve. The first is the type where we have a log on both sides of the equation with the same base. And the other type, okay, so that's the first type. The second type of equation that we will look at is when we just have a single logarithm equal to a number. So in that first type of equation, where we have a log on both sides, we're going to use this property of equality for logarithmic equations, okay, which says that if we have log base b of x equal to log base b of y, then x is equal to y. So basically what we can do is just drop the log base b, and you just have x equal to y. So our first example, we want to solve log base 5 of 4x minus 7 equals log base 5 of x plus 5. So since you have the same base in your logarithm, you can cancel those out on both sides, and you're left then just with a linear equation. So it's just a matter now of solving that. So we subtract x on both sides to get 3x minus 7 equals 5. Then add 7 to both sides, get 3x equals 12, and then divide both sides by 3 to get x equals 4. All right, another example like this, we have the natural log of 7x minus 4 equals natural log of 2x plus 11. So again, it doesn't matter what base logarithm it is, as long as it's the same base logarithm on both sides. So this time we can cross out the natural logarithms, and we just have 7x minus 4 equals 2x plus 11. So again, solving that linear equation, I'm going to subtract 2x both sides, get 5x minus 4 equals 11. Then add 4 to both sides. 5x equals 15. And then divide by 5. And we get a solution of x equals 3. All right, now the second type of logarithmic equation, we're going to use our definition of logarithms again. So we did this with solving exponential equations as well. What we're doing is we're starting now with this type of equation, and we're going to rewrite it as an exponential equation. So by rewriting it that way, we'll be able to solve the equation, because we'll whatever we're taking the log of, okay, will end up being what our exponent is equal to. So we use that definition. So as an example, we've got log base 4 of 5x minus 1 equals 3. So by our definition of log base b of y equal to x, okay, being the same thing as b to the x equals y. Now, our base is 4, so we write it as 4, okay, and our what our log is equal to is the exponent, so that's 3, so 4 to the third equals what we took the base log of, so 5x minus 1. All right, so 4 to the third power is 64, so we have 64 equals 5x minus 1. And now again, it's just a linear equation that we can solve by adding 1 to both sides, get 65 equals 5x. And then divide both sides by 5. And we get x equals 13. Alright, so again, this base of our logarithm becomes the base of our exponent. what the logarithm is equal to becomes our exponent, and what we took the log of becomes what our exponential expression is equal to. And by rewriting it in that form, again, these are equivalent forms, the logarithm and the exponential, we can come up with an equation that is solvable then. All right, a few more examples. Here we've got log base 2, so it will be 2 equal to 5, so to the 5th power equals x minus 6. So 2 to the 5th is 32. Now add 6 on both sides, and we get 38 equals x. All right, another example. Okay, this time we have 4 times the natural log of negative x plus 3 equals 21. All right, so this brings up an important point that we want the logarithm by itself before we switch it into exponential form. So before we rewrite this as an exponential equation, we're going to want to subtract 3 on both sides to get 4 times the natural log of negative x equals 18. And then divide both sides by 4. So we get natural log of negative x equals, and that's 4.5. All right, now before we can write this as an exponential, remember that a natural log is log base e. So when we rewrite it as an exponential, it will be e to the 4.5 power equals negative x. And if we evaluate e to the negative 5th, e to the negative 4.5, we get approximately 90. Okay, so we have 90 is approximately equal to negative x, and then divide by negative 1 on both sides. So we get x approximately negative 90. Okay, one final example. Okay, here we have log base 2 of x minus 4 equals 6. So again, we have a base 2 for our log, so our exponential expression is going to have a base of 2. The log is equal to 6, so our exponent is equal to 6. And then we have what we're taking the log of is x minus 4, so that's what our exponential expression is equal to. 2 to the 6th is going to be 64, equal to x minus 4, and then just add 4 to both sides to get 68 equals x. And that would be the solution. All right, so that's it for target 27. Okay, this is how you solve logarithmic equations.